We're going to solve two problems. A random variable x is Gaussian with zero mean and unit variance. We want to find the following two. So let's first start off with A. For part A, we have the probability of x, the absolute value of x to be specific, bring it greater than or equal to 2. So from here, we can break this up. We're going to have the probability of x being greater than 2 plus the probability of x being greater than negative 2. Now, the next step from this is that we are going to want to kind of take this and expand it a little bit. And this is going to come in handy when we solve for this one because it's kind of the exact same thing. So from here, I'll draw this underlined in red and we'll do the next part in red. We are going to have, if x is greater than 2, we want 1 minus the probability of that x is less than or equal to 2. And so that's going to be for this. Now we are also going to add to this the probability of x being less than negative 2. So we're kind of just switching that around. And what this is going to do is we are going to have 1 minus the f of x of r2 plus f of x of the negative 2. So this step is not entirely important with the switching. I don't fully understand it either, but that seems to be the process. I just know it goes from here to this step, which is important. And the reason why this step is important is because two things are going to happen. So if we look at this one right here, which I'm going to do in blue, for this part right here, it's going to be, and this is just for this entire part right here, this whole thing, we're going to have 1 minus q, then we have this x minus the micro over the unit variance. So this is what we have. So we have the mean, this is the mean, and this is the unit variance. And then for the next one right here, it's a little bit different, where we just have the q, we have x minus the micro over the unit variance. So these are the two differences right here. Now, remember, for this problem, the unit variance is going to be 1. So that means this right here is 1. The actual mean is going to be 0. So this is 0, and this is 1. So remember, the positive one is 1 minus this. The negative one, we don't have a minus, it's just going to be this itself. And this is a chart that we're going to use to solve this. It's actually linked in the description below the like button. When we have this 2, when x is 2, it's going to give us a q of, because of this e negative 2, approximately 0.022, and then we could round it to 8 if we wanted to. But we can leave it off at 7. So essentially here we're going to have 1 minus, if we plug in our q, 0.0227, and then this one is just going to be 0.227 here. So after all is said and done here, we're going to really have 1 minus this part right here is going to give us a 0.97725. The 1 comes from this earlier one, and then we have our plus 0.227. So with all of this together, we are going to get approximately 0.0456. And that's going to be the answer for part A. Now we can look at part B. And in part B, we just have the probability of x being greater than 2. So to go to this next step, because we just have this even part right here, we're going to have 1 minus the probability, where we have our x has to be less than or equal to 2. This looks very similar to what we have in red underline from the top, so we can kind of continue that train of thought. This is going to be equal to 1 minus our f of x, where we pass in our 2, and this is equal to, well, only this part is equal to 1 minus the q of our x, which is 2, minus our mean, which is 0 for this problem, divided by 1. If we check that table in the description below the like button, we know that q of 2 is just going to be a 0.02275. We're going to have 1 minus this for this part, and that's going to give us approximately 0.97725. So we have 1 minus this. 1 minus this from this 1 minus, is going to give us approximately 0.02275. And that's how we would go about looking and solving for this problem.